Reform standards questions the problematic standardization that is widely practiced in all industries. Standardization enhances efficiency and organization, but it generates increasing waste and wastelands due to its homogeneous inputs and process. The one-way process from standard has to be changed to a destandardization control process and to an alternative level of flexibility in standardization. Design has to take the material as input, to take all waste into potential resource, to take all geometries as initial design inputs. The program takes inputs of scan geometry, boundary, and design priority definition into the engine for reinforcement learning searching and generates a shell with construction guidance of each fragment and construction sequences. The program helps to digitize the waste and sort the waste into an inventory, then it generates boundaries according to the inventory and user constraints. Those inputs help the game AI to play millions of times to assemble a shell and produce a construction strategy. The following demo applies with reciprocal plastic fragments to prove the concept with reinforcement learning agents. The program starts from using photogrammetry and depth camera to digitize plastic fragments. After the scanning process, all digital models are analyzed and sorted for future process and sequence of placement. After the analysis, a 2D boundary will firstly be defined according to the total surface areas of the fragments. A 3D boundary can also be generated to facilitate the learning process and construction areas that are defined by architects. In the learning part, a game environment is developed with machine learning algorithms. In the past, reinforcement learning is mostly applied in game engine to train an AI to solve a task. We no longer need to search and compile methodology. Rather, we can now state the goals we want and use reinforcement learning to search for methodologies. What we need then is a game engine that the player can control and AI can take over. So a game system is developed to assemble the fragments in a defined sequence. In the game environment, a player can firstly control the fragment by moving in 3 axes, rotating, and finally placing if it can be properly assembled. Then the reinforcement learning AI can take over and try to play like a human player, and can speed up and play in multiple sets and numbers to achieve the most rewards. With curriculum learning, the agent learns to build a shell step by step, with the vision from the fragment itself to find the assembly point, then to build higher with side camera, and with the top camera to make AI build larger spans. Finally, it achieves the shell-like structure with column-bar structural analysis in real time. The AI will easily win over human players to achieve certain goals and get higher rewards. And with priority setting, the engine can apply multiple ways of observation and vision in real time. The observation of AI allows more machine vision to understand the context and react. Here it receives different lighting conditions to get a variety of shade. Height detection to get the desired height. Camera to capture supports and cover areas. Column-bar analysis to check the stability as a way to find new patterns of structures and optimize. Wind flows to generate different haptic experience. Symmetry observation to define regularity. Different priority settings will generate different best rewarded shells. Finally, users can choose the best shell from a selection of top-ranked results. During the process, users can always edit additional fragments, and the program will step back to the sorting algorithm and resequence the inventory and reassemble the shell with new dataset. After the decision, the program generates guidance of assembly and treatment of each fragment.